In this video, you will learn how to calculate the missing length of the leg of a right triangle by using the Pythagorean theorem. So far, we have talked about how the Pythagorean theorem tells us that if we take the area of the squares off of the legs of the triangles and we add them, it will equal the area of the square off of the hypotenuse of the triangle. We had looked to see that when we had two legs and their lengths, we squared them, added them, and then took the square root. Sometimes we are given the area of the hypotenuse square and the area of one of the legs squares. And we have to figure out what is the area of this square. So if you think about it and just know that if I have the area of the 16, I'd be adding the other small one, and that's equal to 20. So hopefully in your head you can think, well, that small square is going to have an area of 4. And if this area is equal to 4, to find the side length, I would just need to take the square root of it, and it would be 2. Same thing over here. If I know that the area of this square is 10, and this square is 25, the Pythagorean theorem tells us that if I take the small square of 10 and add the other small square, it needs to be equal to 25. So you can see that if I go 10 plus, what number plus 10, it gives you 25? 15. This area would have a 15 for its area. So if I'm looking to see what is the side length of this leg, I'd have to take the square root of 15 to figure out that side length. Let's look at this first example together. I can see here that this would be the right angle because the two legs form the L. So I know one of the legs and I know the hypotenuse. If you think of the Pythagorean theorem, it is a squared plus b squared equals c squared, where A and B are the legs and C is the hypotenuse. So we are looking for one of the legs. So we will just call this one A. It doesn't matter if it's A or B. I'm just going to call it A for this one. So this time I have a leg, just one of them. So I'm going to say we don't know A squared. I do know that 5 is one of the legs, so I'm going to put that in for B. And the hypotenuse, which is C, is 15. So far, all I've done is I've inserted the lengths that I know into the Pythagorean theorem. Once I do that, I'm going to solve what I can. I don't know A squared, but I do know 5 squared, which is 25. And I do know 15 squared, which is 225. So now we got to go back to how we solve equations. I'm trying to figure out what A squared is. And right now, it has plus 25 next to it. So if you think about it, the area of A squared plus that other triangle, the other square is going to equal the 225. So to get A squared by itself, I'm going to solve this like an equation and subtract 25 from both sides. Once I do that, I'm going to get that A squared is equal to 200. So that other square off of the longer leg would have an area of 200. My last step is going to be to take the square root. So the area of the square is 200. To find the side length, I'm going to do the square root of 200. And if you think about what the square root of 200 is, if I want to do a quick estimate of that, I know that 14 squared is 196, so it's just a tad bit over that. So I'm going to say that it's about 14.1, which would make sense because always remember that if I have my hypotenuse, that's going to be the longest side. And see how my answer for this leg is smaller than that. I always double check and see if that happens, just to kind of check to see if my answer seems like it makes sense. Here's a second example that I want you to write down as I go through it with you. So you can see once again, we have one of the legs. We do not know the other one, and we have the hypotenuse. So using our Pythagorean theorem, a squared plus b squared equals c squared, I'm going to plug in the values that I know. So I know that 8 is one of the legs, so that's going to be squared. This time I do not know what b is, so it's going to be squared. And then I know that the hypotenuse is 10, so that's my c, and I put that into the spot that c is. Then I'm going to figure out what I do know. I know 8 squared, so that's going to be 64. The b squared I still do not know, that's what I'm solving for. And 10 squared is going to be equal to 100. So now solve it like we do when we solve our equations. I know that I'm going to be taking 64 plus whatever that value of b squared is, and that's going to equal 100. To help us, we can subtract the 64 from both sides, because that's going to really tell us how much is left over for that b squared. So when I do b squared, and I have to think, okay, 100 minus 64. Just gonna think here, I'm gonna count up. I'm gonna say 64, 74, 84, 94, and then I'd need 6 more to get to 100, and that is gonna be equal to 36. And then my last step is, since that b squared is 36, I need to figure out what b is. So I'm going to be taking really the square root of both sides. So when I get my answer, I'm going to get that b is equal to, this time, 36 is a nice, perfect square. So I know that the square root of 36 is equal to 6. So b is going to be 6. And just think here, see how 10, that's got to be my largest side. 8 and 6 are both smaller. This is another example of what we call a Pythagorean triple, because see how all the numbers are a nice whole number. There's no decimals, we didn't have to estimate, they're just perfect square roots when we did it. So the leg that I just found has a value of 6. I would like you to get your math notebook out and copy down what you see on the screen right now. We're going to put a few notes into your notebook so that we can kind of organize our thoughts about how you use the Pythagorean theorem to find missing parts of the triangle. So pause the video, copy this in your notebook, and then turn me back on when you are ready to go on. So the left side. Steps to finding the missing hypotenuse. This is what we started with when we knew both legs, so the A and the B, and we were looking for the C. So if you think about the steps that you would do to solve this, I think about it like this. For the steps, you are going to take the 3 and the 4, and you are going to square them, right? When you put those in the Pythagorean theorem, what you end up doing is you square both of those values. Step 2, when you're finding the hypotenuse, once you square those numbers, you end up adding them together. So I'm just going to write that step 2 is to add those values. Once you add those values, that's going to give you the value of c squared. So your last step is going to be to take the square root of the number that you just got. The next example, if you are trying to find the missing leg, that is what this video has been about. You really start with doing the same thing. You start with squaring the values. You put them into the Pythagorean theorem, and you end up squaring the values that you are given. After you square the values, this time, instead of adding them, you subtract them. Your last step is the same. After you do that subtraction, you get the area of the square off of the leg, and you have to take the square root. So just look and see, kind of look back at what we just wrote down. Really, the steps are super similar. Step 1 is the same. You're going to be squaring the values. The second step is the only thing that's different. On one, you're going to add the values. On the other, you're going to subtract. And the third step is also the same. So really all you have to know when you're using the Pythagorean theorem is when do I add and when do I subtract. And if you get those things straight, you will be set. Now it's your turn to try a few. I want you to copy down this example and then try it on your own. So pause the video. Once you have copied it and tried using the Pythagorean theorem to find the missing leg, turn the video back on and I will show you how it is done. First step you want to do is insert the information that you know. I know one of the legs. One of the legs is 5. I'm missing the B, so the other leg. I know that 8 is the hypotenuse because it's the longest side and it's opposite of the right angle. Now I'm going to do the squaring. So I took the numbers, I'm going to square them. 5 squared is 25. B squared, I do not know. 8 squared is 64. Once I do that, I'm solving the equation. So I know that I can find B squared. I'm going to take 25 away from both sides so that I can figure out what is that value for B squared. That's going to give me B squared. When I subtract that, that is going to be, let's see, that's going to be 39 when I subtract that. And then my last step is going to be to take the square root. I'm going to take the square root of both sides, so I end up with B is equal to the square root of 39. If I want to do a quick estimate in that, I'm going to think, well, the perfect square of 36 is close by. Square root of 36 is 6, so it's going to be a little bit over that. So I'm going to say that square root of 39 is about 6.2. And if I go up here and look just to see if that makes sense, see how my first leg is 5, my second leg is 6.2, and then my hypotenuse is 8. So 8 is the largest side, so that fits along with what I would expect for the triangle. Here's one more example for you to try. Once again, copy down the problem, try to do it on your own, and once you have finished it up, turn the video back on and I will show you how to do it and what you should have gotten for an answer. Once again, start with plugging in what you know into the Pythagorean theorem. We know one of the legs, which is 9. We do not know the other one, so that's the B squared. And we do know the hypotenuse, so that's 12 squared. I'm going to square the numbers that I know, so 9 squared is 81. I do not know the B squared, so I'm going to just copy that down. And then I get 12 squared, which is 144. Once I figure that out, I'm trying to solve for B squared, so I'm going to subtract 81 from both sides. When I get that, I'm going to say 144 minus 81. I'm going to have to do a little math here because that's kind of a big difference. So I know that 4 minus 1 is 3. Remember from there. So it looks like that's going to be a value of 63. So the B squared is equal to 63. My last step is going to be to solve for the side length. So the area is 63. I'm going to take the square root of 63. Square root of 63 is very close to being a perfect square, which because square root of 64 is equal to 8. So that's going to be a value of about 7.9. If you go up here, let's just take a look to see, does that make sense? The two legs are both smaller than the hypotenuse of 12, so it does fit what you would expect for the length of that leg. At this point, hopefully you feel comfortable with finding the value of the leg of a right triangle using the Pythagorean theorem. If you have any questions, you can ask me, or you can watch some of the examples again and see if you can get a little help that way as well.